in the following network current through the galvanometer is. So here actually we had given a Wheatstone's bridge and we have to find out what is the current flowing through the galvanometer. So let us consider initially that this galvanometer is removed from here. So we are left with branch PQR, which is series combination of 4 ohm resistance with 4 ohm resistance. So the effective resistance of upper branch, that is branch PQR. What is the effective resistance of branch PQR? It is equal to 4 plus 4, that is equal to 8 ohm. While the lower branch, which is PSR, it is series combination of 1 ohm resistance with 3 ohm resistance. So the effective resistance of lower branch, it is 1 plus 3 equal to 4 ohm. 1 plus 3 equal to 4 ohm. Naturally, if I say that some current reaches the junction due to this source of EMF, so that current gets divided into two parts, and if I assume that the current flowing through the branch PQR, it is say, or current flowing through the branch PSR, it is say I, then 2I, then naturally current flowing through the branch PQR, it must be equal to I. Why here I had taken current I through the branch PQR and 2I along the branch PSR? Because the effective resistance of upper branch is exactly double that of effective resistance of lower branch. Higher is the resistance, lower is the current flowing through it. Lower is the resistance, higher is the current flowing through it. So through this branch PQR, if I is the current flowing, then through this branch PSR, 2I is the current flowing, because resistance of upper branch is double that of resistance of lower branch. Now according to Kirchhoff, according to Ohm's law, potential difference between point P and Q. What is potential difference between point P and Q? It is Vp minus Vq is equal to, what is the current flowing between point P and Q? It is I, and resistance is 4. So it is 4I. Similarly, potential difference between point P and S, it is Vp minus Vs, and that is equal to current flowing between point P and S, it is 2I, and the resistance between point P and S, it is 1. So Vp minus Vi is equal to 2I. So we are having two equations. This is equation number 1, this is equation number 2. If I add these two equations, then I will get Vp minus Vq plus Vp minus Vs, and that is equal to 4I plus of 2I. Here, instead of addition, we will subtract equation 2 from equation 1. Vp minus Vq minus Vp minus Vs is equal to 4I minus 2I. So see what happens, plus Vp minus Vp get cancelled. Minus of minus Vs, it becomes plus Vs, and minus of Vq, that is equal to 4I minus 2I, means it is 2I. Or here we can say Vs minus Vq is equal to 2I. Vs minus Vq is positive. It means Vs is greater than Vq. Vs is greater than Vq, means potential at point S is greater than potential at point Q. Means S is at higher potential as compared to Q, and if we connect a galvanometer between point Q and S, so there must be a flow of current from point S towards point Q, because potential at point S is higher than potential at point Q. So out of 4 options, what we can say, that current flows through galvanometer from point S to point Q. So option A is the correct option.